Hi. In the next few minutes, we are going to proceed with the demo of some of the new capabilities of Connext 7.3. Specifically, we are going to showcase 3 new features. Within the productivity area, we are going to showcase the Python API. Within the security area and digital certificate management, we are going to show how to use certificate revocation. Within the observability area, we are going to showcase the new Observability Framework. The Observability Framework allows you to get telemetry data from your TDS Connext applications and store that data into third-party backends for analysis. Those third-party backends can be backends such as Prometheus for metrics and Grafana Loki for logs. The demo application is going to be a Python application. It's going to use the new Python API, and it's going to simulate a patient monitoring system. The application is going to run 3 processes. The first process is going to publish patient data information, in this case, heart rate. And the other 2 processes are going to be subscribing to that patient data information. So you can think of the subscribing processes as nurse stations. The application is running in 2 DDS domains. So the domain on the left, in orange, is the user data domain, which is going to be used to exchange the patient data information. So in this case, the heart rate. The domain on the right is the telemetry data or observability domain. So this is the domain that is going to collect the telemetry data from the 3 processes, and is going to send that telemetry data to the observability framework using a component called collector service. The Observability Framework is going to be running in AWS, and is going to store the telemetry data into a Prometheus backend and a Grafana Loki backend. Prometheus will be storing metrics, which are numeric values counters, and Grafana Loki will be storing logs and security events. So finally, there is this component on the bottom that is Observability Dashboard components. So these Observability Dashboard components are Grafana dashboards that are going to tap into the data stored into the Prometheus and Grafana Loki database. So these dashboards are distributed with the RTI Observability Framework. Now, the goal of the Grafana dashboard is to show the health of the system, okay? And it's just using the 5 golden signals. With that, so let's move to the Python API demo. To showcase or to show the Python API, what we're going to do is to create an example from scratch. And pretty much what I want to show is how easy it is to get started with it. The first thing that we have to do is to create a Python environment and activate that Python environment. And we're going to do that in the publisher window, which is this one, and the subscriber window. Okay. Then after that, we are going to install the Python API. And we are going to install it from the Connext installation that we have in this directory, applications RTI Connext 7.3. Okay. Now we do have Python installed. What we are going to do is just to generate a hello world example. In order to do that, so I'm going to open a Visual Code window, which is going to be empty. And we are going to create a file that is mytype.idl, which is where we are going to define our type. In this case, our type is going to be a hello world type with just a simple message. Okay, let's go back to the command line. And then what we are going to do is to run RTI. So before running RTI, we are going to set environment variables that we need to find the RTI. We're going to do that in both places. Now let's run RTI. You can see that the parameters that we need to generate code in Python is just to set the language to Python. The sample is universal because we want to generate an example in this case, and this is the ideal file. Okay, so now we have our Python code generated. So let's go back to the Visual Code window and take a look into the code that has been generated. So we're just going to open the publisher, and you can see how easy just to write something that publish data, right? So what the publisher is doing is just creating a domain participant and highlighting here. Is creating a topic and a data writer, okay? After that, it creates a sample, and in a loop is going to be writing that sample. So what we are going to do is to change this code so that we can print just a hello world message, that increase a counter with every sample, okay? And the subscriber code is equally easy to understand. So we are gonna go back to the window, and we're gonna run the applications now. To run the publisher, so we're gonna type my type publisher program. Program is just a Python file, just parse command line parameters and just call my type subscriber, my type publisher. So with the -p option, so we are running the publisher. And next we are gonna run the program on the other window with the -s option, which is going to run the subscriber, and you can see that the subscriber is receiving the hello world messages. Let's move on now to the patient monitoring demo. The first thing that we are going to do is just to start our publisher. Our publisher in this case is going to simulate a patient, and it's going to publish patient data, in this case, heart rate. So we are starting the publisher, which has a patient associated with it, a device ID, and a domain. So before moving to the subscribers, I want to go back and show you the IDL that we are using for the patient demo application, for the patient data application, okay? So this is the topic, this is the type of the topic that we are publishing. It contains a device ID, contains a patient ID, and the bits per minute, okay? And so the device ID and the patient ID are the key field. The key field is equivalent to the primary key in a relational database table, okay? So let's go back to the demo. So after starting the publisher, we're gonna start the two subscribers, okay? That are the two nurse stations. So let's start the first one, which is already receiving data. And we're going to start the second one, which is also going to receive the same data from the same patient. So we have now our publisher, and we have two subscribers. And of course, we are receiving patient data, but how do we know, and how do we monitor the system? How do we know that the system is healthy, right? So we are receiving data to the expected rate and things like that. So to do that, what we're going to do is to use the new Observability Framework. The new Observability Framework, we are going to use it by accessing the framework through the Grafana dashboard, okay? The framework is running in AWS. So I'm gonna log into the framework, and I can immediately see that there are 3 applications running with 3 participants, 1 writer, 2 readers, so that makes sense. So I can also inspect or go to the applications and see that the name of the application, in this case, 2 patient monitoring subscriber, and then the publisher. I can go to the participant and inspect the data as well, and so on. So this is a timeline that shows the resources. This is how many resources are created in the system, right? And then the dashboards are hierarchical. So what that means is that you start with the 5 golden signals that are going to tell you if there is a problem related to bandwidth, saturation, data loss, system errors, or delays. And you also have kind of view in this top level dashboard, you have a view of the logs. So for instance, if there was a security event, which we will be simulating in a few minutes, so you will see something here, okay? So once there is an error, you can go deeper and you can go to a second level dashboard, okay, which is going to give you additional information. So that's kind of the way dashboard work, okay? Let's simulate the first error. The first error is intended to showcase the certificate revocation feature. So what we are going to assume is that subscriber 1, okay, or the nurse station that is running subscriber 1 is compromised. So it is not safe anymore. It is not something that we can trust, okay? In this case, what we can do in Connext 7.3 is just to revocate the identity certificate, which is used, okay, to run the subscriber application. So let's do that. So in this case, I have a script that is going to do the revocation. And it's going to do the revocation by adding a CRL to the, in this case, to the publisher application, okay? And the CRL is the certificate revocation list is going to contain the list of the certificates that we are revocating. So let's do that. So once we invoke the certificate, so we can see that the subscriber 1 is not receiving data anymore, okay? We can also see that the subscriber 2, it continues receiving data. Now, in addition to that, we are taking the security event, this revocation security event, and we are sending that to the observability framework. You can see already that there are some security events going on here. And those security events will be stored in this case, for this specific demo, in a Loki log aggregator, in a log database, okay? Now, we are using Grafana Loki in this case, but with Observability Framework and through OpenTelemetry, you can store your log messages in any log aggregator out there that supports OpenTelemetry, okay? And you can see that here we have a few security events related to authentication. So obviously, certificate revocation is related to authentication. So it also tells you a plugin class. And of course, so you can take a look into all details about what certificates have been revocated and so on. Okay, let's go back to the applications. So what else can happen in a Connext system that is running for a long period of time? The other thing that can happen is that there are errors in the system, okay? They could be due to a bug in the application, okay? They could be used to some unexpected or an unknown condition. So how do we deal with that? So I think the Observability Framework is going to help us with that aspect as well. So in this case, so let's simulate in subscriber 2, let's simulate a saturation event. A saturation event can happen because the CPU goes to 100%, for example, okay? So let's see what happened. So in this case, I click this button, so we are simulating the saturation event, and you can see that we are receiving data much slower. So what we want to know is if we are able to detect that situation in the Observability Framework and just provide some error information, and here we are. So the Observability Framework is already telling us that there is a saturation problem and a potential data loss problem. Okay, so we know that that is happening. So, but where is that problem located? So this is where we can click in saturation and go one level down. And I'm gonna maximize this since we're working with this with the framework right now. And you can see here that there are some samples drop due to history debt. So that means that the data reader, so this is a reader cache metric, and it's just telling us that the data reader is not keeping up. As I say, it could be because CPU is just peaking, okay? But let's go inside, because we don't know yet what data reader, right? So what we want to figure out is what data reader is picking up. And I can see here that there are two data readers in my system, and the first one, which happens to be the data reader from patient monitoring subscriber 2, that is the second subscribing application, is the one that is providing an error, okay? So let's go back to one level down, and we can see now, if we scroll down, so here we are kind of plotting all the metrics that we receive from that data reader. Here we can see now that when it comes to the drop samples due to resource debt, to history debt, we are kind of crossing to the red area, and that means that there are some errors, okay? So we are dropping samples. An interesting aspect of observing your system is that you may not want to push all the telemetry from the get-go, right, from the beginning, just to optimize resource utilization. So with the Observability Framework, you can control both. You can control the logs that are collected and distributed with the framework, and you can control as well the metrics. So let's go back for a second to our applications. So let's assume that there is a problem on the publisher application. So we are gonna go here. I'm gonna put some spaces here so that we can see what's going to happen. And we want to enable the logging verbosity. We want to get logs not at a warning level, but at potential and informational level. So how do we do that? So we can go to an application in the Observability Framework. In this case, we're going to go to the patient monitoring publisher. And you can see that on the last level. So we have the option of configuring the log verbosity at runtime. So we get into a window that allows us to configure both the collection, that is what the application produces, and the forwarding, which is what is going to be sent to the backends. In this case, let's just change the collection and let's make it informational, okay, and see what's happening. I'm going to put a few other spaces here. So we confirm, and we can see that immediately the application starts producing more log messages at informational level, okay? So let's go back to the error. And once we have errors, so we only produce errors, so we are not going to produce any more local messages, in this case, informational messages. Okay? Now, the same thing that you can do with logs, you can also do with metrics. So I could go to a data writer, in this case, the publisher data writer, click on the data writer, and just configure the data writer metrics that I want to receive. And it's as easy as just selecting the metrics that you want to receive and just enable or disable these metrics, okay? So I could potentially say, well, I want to disable, okay, the metric that tell me how many heartbeats have been sent, or the metric that tell me how many sample bytes have been pushed, because I already have the samples, I may not want the bytes. So it's just as simple as going here, configuring your metric, and just get that going. So that's it. So hopefully this demo has given you an idea of some of the new capabilities of Connext 7.3. As I say, just to repeat, the Python API, some of the security capabilities, specifically certificate revocation, and of course the new Observability Framework. Thank you very much.